Namaste. Today in this video we are going to derive an interpolating polynomial for Gauss backward interpolation. It is similar to the Gauss forward interpolation, but the difference is only in the involvement of various terms. So let us consider the table same as Gauss forward interpolation. Okay, x y del square del cube del power 4 del power 5 del power 6. Okay, so let it be x minus 3, x minus 2, x minus 1, x naught, x1, x2, x3. So it is y minus 3, y minus 2, y minus 1, y naught, y1, y2 and y3. So it is del y minus 3, del y minus 2, del y minus 1, del y naught, del y1, del y2, del y3. Similarly, del y minus 3, okay, square. Okay, so del square y minus 2, del square y minus 1, del square y naught, del square y1, del square y2. Okay, now del cube y minus 3, del cube y minus 2, del cube y minus 1, del cube y naught, del cube y1 and del power 4 y minus 3, del power 4 y minus 2, del power 4 y minus 1, del power 4 y naught. Okay, del power 5 y minus 3, del power 5 y minus 2, del power, okay, this one is I think neglected, so this one is removed. I have written more terms, so sorry. So this one is removed. Okay, and this is, and lastly it is del power 6 y minus 3. Okay, this one is because del y2 is y3 minus y2, so this is not written. Okay, in Gauss forward interpolation we take this central element and this and move upward, yes, this and this and move upward, this and this and move upward. But in Gauss backward it is similar, but there is certain change. So this one is okay, it is same as Gauss forward interpolation. In backward we take after this part. Okay, and same. Okay, this is the center of 5 points and again move upward. So this is, and again move upward. So this. Okay, so these are the changes. In Gauss forward we take this and this and this. Yes, in Gauss backward it is somehow different. So this and this and this. Okay, now we write the similar interpolating polynomial as in Gauss forward. So let it be yp equals to y naught. Okay, first y naught plus g1 del y minus 1, y naught plus g1 del y minus 1 plus g2 del square y minus 1 plus g3 del cube y minus 2, yes, plus g4 del power 4 y minus 2 plus g5 del power 5 y minus 3 plus g6 del power 6 y minus 3. So it is different than Gauss forward interpolation. Yes, that let it be as equation 1. Now the g1, g2, g3, g4, g5 and g6 are constant. So LHS, we use the same process as in Gauss forward. Okay, so y LHS is yp, and by using the shifting operator, that is e power p y naught. So E means 1 plus delta. Yes, we have use in the Gauss forward interpolation, and when we expand it, we get it as 1 plus PC1 1 power p minus 1 delta plus PC2 1 power p minus 2 delta square plus PC3 1 power p minus 3 delta cube plus dot 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 plus PCP 1 power 0 delta p power y naught. Yes, it is similar to the Gauss forward interpolation. So it can be written as y naught plus p delta y naught plus p into p minus 1 by 2 factorial del square y naught. Yes, this means p into p minus 1 divided by 2 factorial del square plus p into p minus 1 p minus 2 by 3 factorial delta cube y naught plus dot 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 dot. Okay, and again same as in previous, we check the RHS. Yes, so the RHS is, what is the RHS? It was y naught plus g1 delta y minus 1 plus g2 delta square y minus 1 plus g3 delta cube y minus 2 plus g4 delta power 4 y minus 2 plus g5 delta power 5 y minus 3 plus g6 delta power 6 y minus 3 plus dot dot dot. Okay, it was like this. Now similarly in Gauss forward we use this and shift it to y naught. So y naught plus g1, when we shift it, it gives e power minus 1 y naught. Yes, okay, delta e power minus 1 y naught. Similarly g2 plus delta square e power minus 2 y naught plus g3 delta cube e power minus 3 y naught. Sorry, it is minus 2, not minus 3. Since it is minus 2, it is minus 1. Okay, plus g power 4 delta power 4 y minus 2 is converted into y naught by shifting backward 2 times, plus g power 5 delta power 5 e power minus 3, when we shift backward 3 times, it gives y0. Similarly g power 6 delta 6 e power minus 3 y naught. And what is the value of e? It was 1 by delta s. Y naught plus g1, okay, delta is 1 by delta, 1 by 1 plus delta, so y naught plus g2 del square is 1 by 1 plus delta, okay, and y naught plus g3 del cube 1 by 1 plus delta square, okay, whole square it is, y naught plus, okay, I will neglect the next term, please write it itself, and we get it as y naught plus g1. When we expand this, we get it as delta minus delta square plus delta cube minus delta power 4 dot 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 y naught plus g2. When we expand this, it starts with square. Okay, since delta, so it starts with delta, it starts with square. Delta square minus delta cube plus delta power 4 minus dot 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 dot. Okay, it is y naught plus, so it is del cube, so it starts with del cube. Okay, G3, simple approach. So del cube minus del power 4 plus del power 5 minus dot 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 y naught plus, okay, dot dot dot. So that is y naught plus, it gives G1 y naught. Okay, we obligate the larger power of delta. Okay, so delta y naught plus G2 minus, and when we take common, so G1 delta y naught, and there is G1 delta square y naught, so G2 delta square y naught. So we can take common part between these two, so that means we get G2 minus G1 delta square y naught plus, similarly up here is cube, and here is cube, so we can take common between 3, G1 minus G2 plus G3 delta cube y naught. When we open brackets, we can take the common. So comparing this with this, okay, we get, comparing RHS and LHS, okay, we get it as, okay, we get it as, so we can compare these two. Okay, by comparing these two, we get it as P is equals to G1 or G1 equals to P. Okay, we can reverse the relation also, and G2 minus G1 is equals to, what is the value? P into P minus 1 by 2 factorial, and that of G1 minus G2 plus G3 is equals to, this one value is P into P minus 1 P minus 2 by 3 factorial into the, okay, this is the value of this. Now we have to find the value of this. So G2 is equals to, what is the value of G1? It was P, so G2 equals to P into P minus 1 by 2 factorial. When minus G1 is moved to that side, it got, so value of G1 is P. So this is the value of G2. So this is the value of G1. And what is the value of G3? So G3 is equals to P into P minus 1 P minus 2 by 3 factorial. So when G2 is going to that side, plus G2s, so G2 is P into P minus 1 by 2 factorial plus P, and G1 it goes that side, it gives minus P. So this is cancelled. So G2 is, so this, and G3 is P into P minus 1 P minus 2 divided by 3 factorial plus P into P minus 1 by 2 factorial. Yes, when we solve, we can get it is as a simple form as P into P plus 1 by 2 factorial also. And when we solve this, we get G3 as P into P plus 1 P minus 1 by 3 factorial. Okay, similarly we can get G4 equals to P into P plus 1 P minus 1 P plus 2 divided by 4 factorial. Okay, similarly G5 can be getted, and the required polynomial becomes yp is equals to y naught. So G1 is P, yes, so P del y minus 1 from the table, yes, P del y minus 1 from the table, plus, and what is the value of G2? We have found P into P plus 1 by 2 factorial, so it is del square y minus 1 plus, What is the value of G3 we have found? P into P plus 1 and P minus 1 divided by 3 factorial into del cube y minus 2. Similarly, so this is the required Gauss backward interpolation polynomial. Okay, in next video I am going to derive interpolating polynomial for Stirling or Starling interpolation. Thank you.